Welcome to a lesson on volume of a cuboid and a cube. Let's start by talking real briefly about how to find the volume of a cuboid. Here we go. Side note, everything except for this example is in your textbook. So you should definitely draw this picture first. You can pause it now and then basically write what I write. Let's first talk about the volume of a cuboid. Can you find the volume of this cuboid in cubic units? Pause now, try it out, and see if you're right. Well, if we wanted to go crazy, we could actually fill this rectangular prism, this cuboid, with a bunch of 1 centimeter by 1 centimeter by 1 centimeter cubes. That means 10 of them will fit all the way across, and 4 of them will fit back behind the screen, yes? And 5 of them will fit up. We don't really have to do that. We could use a volume formula, and that volume formula is equal to length times width times height. And it doesn't really matter which one we put first, just as long as we include all 3 dimensions, because it's a cubic, and cubic is talking about the 3. Now, if we were to find the volume of this specific cuboid, that means we're multiplying 10 centimeters by 4 centimeters by 5 centimeters. Notice how I included the units here just to demonstrate that we're actually multiplying units as well, because centimeters is a linear measurement, and if we multiply it by itself 3 times, it becomes a cubic measurement. Do you know what it's called when you multiply it by itself once? Centimeters times centimeters. Well, I can multiply these numbers 10 times 4, so I get 40 centimeters squared. Aha, that's what it's called, squared units. And to get a final answer of 200 centimeters cubed. What is that? That's centimeters cubed. That's how, some scientists might call it. But these are cubic centimeters. So pretty straightforward. You'll do a bunch of those as you practice this particular concept. Now, let's talk about a volume of a cube. And we're going to spend a little bit of time on this here. So when you're taking notes, you're calling this volume of a cube, and this is on textbook page 54. We're trying to figure out how many 1 centimeter cubes are used to build this. Now, you basically need to know that each one of these little cubes is a 1 centimeter cube. So, given that, we could actually do this problem without too much difficulty. Oh my goodness, my drawing was a little incorrect. These are it's 4 by 4 by 4. So 4 across, 4 down, and 4 deep. Let's just think about, it's kind of like a Rubik's Cube, Let's just think about how many of these 1 centimeter cubes are on the top row, the top level of this. And we could just count, right? 1, 2, 3, 4. In the first row in front of us, 1, 2, 3, 4 behind there, 1, 2, 3, 4, 1, 2, 3, 4. 4 times 4 is 16. Now that whole top row, 16 1 centimeter cubes, we can multiply that by 4 levels, like 4 stories. 1, 2, 3, 4. So what we really did there is 4 times 4 times 4, which is equal to 4 cubed. Hey, this is a cube. But what we did first was we did the top level is 4 times 4, which is 16. And then we realize that there are 4 levels, so we take that 16 times 4. And I would like you to commit this to memory. 16 times 4 is 64. Let's memorize it. 16 times 4 is 64. 16, 4, 64. 16, 4, 64. Okay, got it? So the answer to the question actually is 64 1 centimeter cubes. We could stack them on top of each other and create this Rubik's Cube type thing. Let's take a look at another example. Same page in your textbook, and this is still a volume of a cube, but we don't have that detailed picture like we had before. Notice this is all sketched out for us into 1 centimeter cubes. And the question here is, how many 1 centimeter cubes are used to build this? Okay, first we have to know that this is indeed a cube. All right, so let me just tell you that this is a cube. that means that that 5 centimeters there is 5 centimeters here, and this is a 5 centimeter height as well. So going back to the very first idea of the volume of a cuboid, well, a cube is a cuboid. A cuboid is not a cube. So a cube is a special type of cuboid, one in which all 3 sides are the same length. So the volume is length times width times height, and the volume is 5 centimeters times 5 centimeters times 5 centimeters. Okay, we're doing something special here, and I want you to see that. We did something special here, 4 times 4 times 4. We're doing something special here, 5 times 5 times 5. All right, so that's 25 centimeters squared times 5. Look at the timestamp on this video. 5:55 right now. Yes! Okay, now let's do 25 times 5 in your head. No calculator, no pencil, paper, nothing. Okay, think with me. 25 times 5, 25 times 5. How can we do that? Let's take 25, which is a quarter, like a quarter in your hand that you're paying somebody with. 25 times 4 is $1 or 100 pennies. And then if we have another one of those, we have $1.25. So what this is 125 centimeters cubed, or 125 pennies, right? Well, those are circular. Those don't really fit inside here. How would we do that? We have these pennies, bunch of pennies. Okay, okay, let's do that. Give them some hair. Okay, or are those bubbles? I'm not really sure. Okay, anyway. I want you to commit that one to memory. 125 is 5 times 5 times 5. It's 5 times itself twice, but 3 5s, okay? So 3 5s multiplying twice. So it's not really 5 times 5 times 5, not 5 multiplied by itself 3 times. There are 3 5s multiplying twice. All right, so 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. Let's build a table. Take a moment, pause the video, build a table like this. We're going to have 10 rows. 10 rows for each edge of a cube. So 1 centimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and this could be centimeters or inches or feet or miles, whatever. That'd be a crazy cube, right? And we're going to try to commit all these to memory. So how do we find the volume? Volume, that's what we're doing here. How do we find the volume of a cube that's 1 by 1 by 1? Well, let's do 1 times 1 times 1. That's 1. Units cubed. Okay, maybe I'll just do this. Units cubed there. Okay, let's do 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, okay. 3 times 3 times 3. Not 3 plus 3 plus 3 plus 3, that's 9. This is 9 times 3, which is 27. 4 times 4 times 4, we know already. 5 times 5 times 5, we're trying to memorize that in the moment right now. 6 times 6 times 6, I'll give it to you. That's 36 times 6, which is 216. All right, you did that 64 and 125, right? Notice these numbers are getting bigger, obviously. These numbers are getting bigger. As you increase these by 1, these are increasing in a different way, in a times E3 sort of way. All right, let's do 7 times 7 times 7. That's so lucky. That's 49 times 7, kind of big, 343. And 8 times 8 times 8, which is 64 times 8. That's a tough one for me to memorize. 512. Some of your parents or you might even have a phone that has 512 megabytes on it. Or sorry, gigabytes. What am I thinking? Okay, and then 9 times 9 times 9. For some reason, this is kind of easy for me. Is 729. Those numbers add up to a number that's divisible by 9. So that 7 plus 2 is 9, plus 9 is 18, divided by 9 is 2. So I think that's kind of cool. And then 10 times 10 times 10, you should all know it right away. It's 1 with 3 zeros. All right, so hopefully you have that table in your paper. If not, you could pause it and jot it down. Hey, this could be a good time to take a break. I only have 2 more examples, so stick with me. I'm thinking maybe 5 more minutes. But this next one is really basic. It's just asking for the edge of a cube that's made of 729 1 centimeter cubes. This could be a good question we ask you, you know. What would be the edge of the cube that corresponds to 729? Oh, let's just look in our table and we could see it's right there. So it's a 9 centimeter cube or 9 centimeter edge. All right, so it's right there on the table. And then you can do a little challenge of what's the volume of a cube, or if the volume is 1331, what's the edge of that cube? 1331. See if you could work that out. All right. Shapes made with 1 centimeter cubes. This is textbook page 55. So you should be open to that. And I'll just tell you right now, this solid is made from 2 centimeter cubes. So just like the picture you see in your textbook. So that means I could call this 2 centimeters and this 2 centimeters, you know, and this over here. Okay? And you know, your textbook tells you the number of cubes that are in the picture, but we could figure that out, you know. Let's just do that together. The only way that these cubes in the back here could be up here is if either they're like glued to this piece or, you know, on some sort of stilts. But really we're assuming that they're on other cubes as well. So I'll just count these. There's 1, 2, 3, 4, 5, 6, 7, 8. And then there are 2 underneath these. I guess I'll say here. There are 2 of them there, like 9 and 10. And that's, you know, that's something that your textbook gave you. Okay, whoop-de-doo. So now we have to figure out, like, what's the best way to do this, you know? Like, maybe you want to actually find the volume of this cuboid that I'm kind of highlighting here, and then add this cuboid. Okay? Now, there isn't a straight formula for this whole thing because it's not a regular rectangular prism or cuboid or cube or trapezoid or whatever. So, but I really think the best way to solve this question is to find the volume of one cube, which is 2 times 2 times 2, which is 8. And then multiply that volume by however many cubes that we have. And we have 10 cubes. Okay, so volume equals 8 centimeters cubed times 10 cubes. There's no unit to that. I mean, really the unit is cubes. So that's 80 centimeters cubed. And I did it the way that I originally had mentioned it too. I just did a blue and a green, so you could pause it and make sense of that. 64 plus 16 is 80. All right, I have one last example for you, and it's basically working backwards. Generally, always something that we do in math is we do something one way, and then we try to do it backwards to see if we actually understood it well. So in your textbook as well, but basically the question is saying how many cubes of edge 2 centimeters are needed to build this cuboid. All right, so 1 centimeter is pretty simple. We could just find out what the volume is, 10 times 10 times 6, and divide it by 1. But it's a little bit different for this case. So I'm just going to start by sketching, you know, some cubes in here, and I kind of want to fit like 5. Let me try that again. So that's 5 pieces for the 10, and then here's maybe 5 pieces for this 10, and then here is for the 6. Okay, what I'm showing you is here's a 2 by 2, here's a 2, so there are 3 that fit into the height. And 5 across. So there are 15, 3 times 5. Getting a little sloppy here, huh? So I could just kind of create this visual that can help us count these. And I think I want to do it a little bit different than that first example that we did, which is basically to think about how many are in the front here. So let me just do that 3 times 5, which is how many that we see just in the front, you know, like as if we were at a store buying something from the front part of the shelf. And then we're going 5 deep, so we could do 15 times 5. And let's think about that. Do we have that? 10 times 5 is 50, plus 5 times 5 is 75. So that's 75 cubes. And those are 2 centimeter cubes. I did that fairly quickly because I want to show you this. What if I just found the volume of this entire thing, which is 10 times 6 times 10, which is 60 times 10, so 600. So that's the volume of the entire thing. Now the volume of the little cubes are 2 by 2 by 2, so that's 8. So then what we need to do to solve this actual question the most mathematically, so not visually, is to do, so the number of cubes would be equal to 600 divided by 8, which is, it's got to be 75, right? It's got to be. And I think about 8 going into 60, that's 7 times with 4 left over. That 4 becomes the little 4 in front of the 0. 8 goes in the 45 times. Okay, wow, that was a jam-packed lesson. I hope you got all that. I hope you got some good notes. You can always come back to this video, watch it any time, but that's all I have for you right now. Thanks a bunch.